My commute to FIU from my home in Northeast Broward County takes on average 51.6 minutes with a standard deviation of 4.67 minutes. Assume these travel times are normally distributed. What is the probability that on a randomly selected day my commute takes me less than 60 minutes? Okay, so let's identify some key phrases here. First thing we see is that it says that my commute to FIU from my home in Northeast Broward County takes on average 51.6 minutes, standard deviation of 4.6 minutes or 67 minutes, and it says assume these travel times are normally distributed. So normally distributed is very important. Let's just use the bell curve. Then it says what's the probability that on a randomly selected day my commute takes me less than 60 minutes. I haven't mentioned this in the previous videos, but I just want to point out that the fact that we're only looking at a single randomly selected day is going to be important later on. So let's just realize that in all these problems we're only looking at one randomly selected item. Okay, so let's draw the bell curve because we know that it's bell-shaped in distribution according to this phrase normally distributed. So I'll put my little drawing aid here. All right, and okay, so there's our bell curve. We'll label the mean and the standard deviation off to the left like we always do. The mean here is going to be 51.6 minutes and standard deviation of 4.67 minutes. Then we'll have a z-axis with the center at 0 and an x-axis that represents a commute length of time, and the average commute length is 51.6 minutes. Okay, so that goes in the center. Now we're looking for the probability that on a randomly selected day my commute takes me less than 60 minutes. Now 60 is to the right of 51.6, so I'll put it here on the curve on the right hand side. And less than means I should shade to the left, so we'll go to the left here. Okay, so there we have it, we shaded to the left. Now, next step normally after we shade the curve is to go ahead and I look up 60 on the z-chart and get my area, but I need to convert 60 into a z-score first. Okay, so let's go ahead and do that then. Z will be equal to x minus the mean over sigma. So I want to convert this commute length of time into a z-score. So I'm going to convert 60 by doing 60 minus the mean of 51.6 and divide by the standard deviation of 4.67. All right, let's see what that gives us. So we'll have 60 minus 51.6 and then divide that by 4.67. Okay, so we end up with 1.798, which will round off to 1.80 because our table only uses out to the hundredths place, so we'll need to round that off to 2 decimal places only, so 1.80. All right, now when we look up 1.80, we'll get the area from here to the center. Always remember we only get the area from there to the center. In order to get this other half of the curve, we have to recognize that we shaded the entire half, and that half therefore represents 50% of the area. So I'll write that as 0.5000. Now if I look up 1.80 and get the area from here to here, I'll have the 2 shaded parts and I'll add them together to get my final answer. So let's go to the chart now and look up 1.80 and see what we get. Okay, so we're looking at 1.80, so we're going to move the table up here a little bit so you can see 1.8. Alright, so here at the 1.80 position, we find the number 0.4641. Okay, so we get the answer 0.4641 as the area from this line to the center. That means the 2 total areas added together will give us 0.5 plus 0.4641. That's the area for the entire shaded region. And when we're done, that gives us 0.9641. All right, so as a probability statement, the probability that a commute x is less than 60 minutes in length is equal to the probability that a z-score is less than 1.80, right? And that probability is equal to 96.41%.